For this activity, you are asked to come up with, in step 1, 2 different integers and insert an inequality symbol between them to make a true statement. If I pick 2 even integers, it could be -4 and 2. Okay, 2 even integers. And then the inequality symbol I would put between them is less than, because -4 is less than 2. For step 2, it says multiply each number in the original inequality by 2. -4 times 2 is -8. If I multiply 2 times 2, I get 4. -8 is, bring down the symbol, less than 4, and so to answer this statement the question, is the new inequality statement true? I say yes. Now for step 3, I'm going to multiply each number in my original inequality by -2. So -4 times -2 is a +8. 2 times -2 is a -4. And the question, is the new inequality a true statement? Is 8 less than -4? And the answer is no. For number 4, I'm going back to my original inequality statement. I'm going to divide each one by 2. So -4 divided by 2 is -2. 2 divided by 2 is 1. Is -2 less than 1? Yes, it is. For step 5, divide each number in the original inequality by -2. -4 divided by -2, -4 divided by -2 is a +2. 2 divided by -2 is a -1. Is 2 less than -1? No. So you should easily see the pattern here that in steps 2 and 4, when either multiplying by a +2 or dividing by a +2, the resulting inequality is true. When I multiply or divide by a negative number, or in this case a -2, the resulting inequality is not true. I had to answer no. So you should see the pattern here. Multiplying and dividing by a positive number results in a true inequality. Multiplying and dividing by a negative number results in a false inequality. So let's do some critical thinking to see what we can do about that. So the critical thinking question at the bottom asks us, since we repeated it with a new pair of integers, we just got done doing that, in steps 3 and 5, what could we do to the inequality symbols to make the statements true? Well, the answer is we can reverse the symbol when we multiply or divide by a negative number. So let's look at some examples. Example 1, A is being divided by 2, and that is less than -9. We undo division by multiplying both sides by 2. I show my work. Multiplying by a positive number results in a true statement. Therefore, I bring down the variable, bring down the symbol, do the multiplication, -9 times 2, and I graph my solution. There was no need to reverse the symbol because I multiplied both sides by a +2. Example 2, D is being divided by -11, and that is less than or equal to 6. To undo dividing by -11, I can multiply both sides by -11. Based on what we investigated above, when you multiply or divide by a negative number, you must reverse the symbol to keep the statement true. So I cancel my 11s and I bring down my D, but I reverse the symbol. Do 6 times -11, and this is what I graph. It's a closed circle because the symbol is greater than or equal to. Okay, on to the last two examples. Example 3, -7 times s is greater than or equal to -84. To undo the multiplication, I must divide on both sides. I'm dividing by a -7. Again, what we investigated above. When you multiply or divide by a negative number, you must reverse the symbol in your solution. So bring down the s, reverse the symbol, and then do the math. A negative divided by a negative is a positive. This is a positive 12. It is a closed circle, and it points to the left. Example 4. 4m is less than -60. I'm undoing multiplication again with division. This time I'm dividing by a positive number. Multiplying and dividing by a positive number does not reverse the symbol, so I keep it. -60 divided by 4 is a -15. It does not matter that my answer when I multiplied or divided was a negative answer, right? It only matters that if the number you are using to solve it, the number you are using to multiply or divide on both sides of the symbol is negative, then it will reverse it. So I graph m as less than -15, so it's an open circle and it points left.